Hello friends, welcome back to my channel and welcome to this another one more video on the AI generalist mindset. So before we start, I just want to take some time. So I've started this series on the AI generalist mindset and the link is there in the description. So in this we started with RAG and we have seen the first step is that is data collection, and then we have seen some steps for data cleanup and then convert it to the markdown. And in that series there is one more session I'm going to start is uh, data chunking strategies. So what are the data chunking strategies and what are the things involved in it? So let's get started. So it is a simple to advanced chunking strategies related discussion, and I'm going to start with some basic thing. So step 2.4, that is data chunking. So there is some theoretical part first. So it is a critical processing step of splitting a large document into smaller, manageable, and semantic pieces, or so called as chunks. That will help us in multiple ways. So this allows the retriever, the RAG, to efficiently find relevant information and fits within the LLM's limited context window. So there are a lot of things in the picture. So that is first thing is the context window of the LLM. It improves accuracy and reduces hallucination, which is one of the important part. So let's get started. So what is chunking? So technically the purpose is to ensure high quality retrieval by breaking down data into meaningful units and allowing the system to focus on specific info rather than the entire document. Yes, because if there is a big info, let's say there's a policy document or some manual or some big documentation, so we want to have tailored response. That is why we need to do chunking strategies. So common methods include fixed size chunking, paragraph based, sentence based, and semantic and all. So we'll see one by one these strategies. Overlap, so crucial technique where chunks share content at the edges to ensure no context is lost during the split. So this also we'll see in subsequent part. Impact, so poor chunking leads to irrelevant and fragmented or missing information. So while the optimal chunking increases the retrieval precision and coherence. So yes, so all the things matter when we do chunk the data content, right? Right. So that are there are some popular techniques, and we will see one technique which is very simple. That is fixed size chunking. So it is a simple splitting based on the character or token count, often with overlap. So this is one of the very early introduced technique where we divide the entire input data source. Let's say it's a document or a PDF with some fixed number of characters or fixed number of tokens. Okay, we'll see one example also. Now, other techniques such as recursive character splitting, semantic chunking, and so on. So those will be taken in the new video. But in this video, we'll see the basic fixed size chunking, and at the end, we will see one bonus uh, content also. So let's get started. Right, so fixed size chunking. So if you can see, there's one PDF or a document, and we are dividing it into typically, let's say, 500 characters. Every 500 character we will have different chunks. So benefit is simple and easy to implement because just like read it as a text and then split it at 500 characters level. It is consistent chunk size for uniform processing, yes, and reduces memory overhead when configuring RAG system. Okay, it's very simple, straightforward, and easy to implement. It divides the text into equal size chunks of fixed numbers. Let's say 500. Okay, right. So yeah, so why it is used despite the cutoff risk. Now what is the cutoff risk? Let's say you there is one sentence which is going to complete at let's say we're doing chunking of 500 characters, and the sentence last word ended at 500 fourth character or 510th character. So now we have chunked it, and then we missed that complete info, right? So that will be, so the first chunk will have little incomplete info, and the second chunk will also have the starting characters as incomplete info. So there is a cutoff risk. Okay, right. So but still, where fixed size chunking is useful, so where we have a strict limit compliance. Okay, so LLMs and embeddings model have hard context windows, for example 502 or 1024 1k or 8k tokens. So where we have this limitation, it's a strict limitation or hard limitation, then we have to go for this kind of fixed size chunking. So token chunking guarantees you never send a chunk that exceeds these limits, preventing some API errors, right? So nowadays, because these LLM models are and this open these AI tools, we can pass them some data, okay. But if you pass them a PDF of, let's say, 500 pages or 600 pages, or maybe something which is more than the allowed limit, then technically the API, the backend will give you an error. So for that we need to have strict compliance, and that is why there's a fixed chunking limitation. Predictable performance, it makes vector database storage and retrieval speeds highly consistent because every vector represents a uniform amount of data. Again, something which is related. So when we have a vector database where the chunks are stored, and then if it exceeds a certain limit, then it becomes difficult to manage, for a longer time. Let's consider there is a vector database, and each unit or each record may be of, let's say, 10 MB. Okay, so storing the record may not be a problem, but then every time retrieving the 10 MB data and then again, giving it to the user. So the data, uh, there's a cost involved for data processing, data storage, data retrieval. So that is why there is a limit. Okay, and that is why we have a fixed size chunking, predictable performance. Efficiency, yes, it requires a zero linguistic analysis, no sentence detection or semantic logic, making it the fastest way to process millions of documents. Again, it is a very straightforward and efficient because it's hard-coded limit of 500 characters or whatever, 1K characters or 2K characters. So that way, automatically, inherently, it will have the efficiency part. Okay, of course, there are some disadvantages, as I said, the cutoff risk and all. But yes, in many places we use this fixed size chunking. Then, so where are the situations where this technique is a must? Okay, fixed size chunking. So let's say high volume log analysis. Okay, so when we need uniform slices of data. Yeah, so consider a very huge system, okay, where there are you know uh, MBs to gigabytes logs are getting generated every day at the backend, and then those has to be analyzed. Let's say, let's say some gaming industry or banking industry or whatever industry. So log analysis is a big part, and then if we do not do a fixed size chunking, then it becomes difficult to parse it or analyze within the given time frame or effective analysis. So that's why fixed size chunking is the one of the good option here. Strict token based billing, okay. So working with tight API budgets, right? So this is again, as we discussed, we need to definitely the AI model whatever we are using, or this open AI, or this open, or the whatever AI paid tools we are using, there we need to have certain limit on the token. Of course, earlier there was very less limit. Now the token is increasing, but then again there is higher limit, but there is a limit. So why there is a limit? Because it's a cost involved. The token processing has some cost involved, and so let's say we purchase some paid tool, so that will also have some limit, some tokens or credits, so to say. So there is a strict token based billing wherever we use, then we need to use for the fixed size chunking. Uniform data tables, when chunking rows of raw data or CSVs. Yes, it becomes a natural option because it's a tabular structure and the data is uniform, so you can do fixed size chunking. Real-time streaming data. So when you need to process data on the fly with very short latency. Okay, let's say there is a podcast going on, and then on the fly um the discussion, which probably in one language, let's say in English language, has to be converted into some other language, and that should happen on the fly. So we can employ other techniques also, but fixed size chunking will give you a lot of effective text conversion or the subtitle generation instead of going for the other technique. So if you go for other techniques, it will happen, the text will be, the speech to text will be converted perfectly, but it will be delayed. So if you want to avoid that, go for the real time, go for the fixed size chunking, right? Okay, so enough about the theoretical part. Let's see one demo. So, by the way, this entire source code is available in my GitHub repository. Okay, so step 2.4, 2.2. inside this sub 2.4 is chunking, and there is a fixed size chunking. Okay, so the link is available in the description. So we are seeing this example, right? And there is a readme page. There's the readme page where you can see these details, right? Just click on this, so you will be in the chunking part. Okay, now the demo part. Okay, so here the scenario is, here there is a scenario which is basically high volume log analysis. So there are some services, just an e-commerce example, user service, order service, payment service. There are some actions, for example, get, post, put, and delete, CRUD operation, and there are some status code which are getting updated. Okay, so based on user action, these are the services being called, these are the APIs being called, and the logs which is generated will have this particular uh, info. Okay, very simple, very straightforward. And in a day, or on a weekend, there is a huge log getting generated, right? So I have a method which will generate the logs. Okay, and it will have some random service name chosen, then the action chosen, status chosen, and the log will be appended, right? Okay, so logs are generated, and it will be dumped into this demo logs.txt. So as of now, there is no demo log.txt. So let me delete this. So let me delete. Okay, so there's no logs as of now, right? Okay, so this will generate the logs, and then there's a method which will do fixed size chunking. Basically, simple method which will just chunk with a different size. Okay, 500 characters or n number of characters. Okay, so for now I'm saying chunk size is 100 characters. Okay, instead of 500, I'm going for 100. I'm calling this method which will do chunking. Now there is some step which is visualizing the step-by-step outcome, and some content extraction is there. Now this is the log generation, data generation part, and now I am doing the clean new lines for display purpose. Some overhead I'm doing, and then I'm just showing the chunks. Okay, now come the validation part. Okay, so okay, we'll come to the validation part in a bit, but for now let's just run it, and it will show the chunks which are getting generated, right? So the total chunks were 990, and these are the first 5 chunks. I can print the other chunks, but these are the chunks. Okay, so if you see the first 50 characters of each chunk 1, chunk 2, chunk 3, up to chunk 5, I can go for next 85 chunks. Okay, right. Now this is about the implementation part, or something which from the developer. Okay, that the chunking is done. Now, being from the automation or from the testing side, I want to verify this step. Okay, whether the log, whether the high volume log analysis, or basically this fixed size chunking is happening really or not. So then I will do a verification. So that is why this second code, which will do the actual verification. Okay, so basically it will go and open every chunk, and it will check the size and so on. Okay, so once again, let me delete this file and run this code. So it will generate the logs, and it will also check the chunk. Okay, so here again the first 5 chunks are generated. Total so data loss check, there is no data loss. Okay, fragmentation rate 100%. Okay, total chunks are 90. Okay, so it is matching. Sample chunk audit, so chunk 1 fragmented, two lines found. Okay, that is fine. Okay, so let me open this. Okay, and so on. So the first the first part, this one, that is working. Okay, sample chunk audit. Okay, this is nothing but some warning message, but anyways, right? So that is for the um, fixed size chunking demo. Okay, let's do one more thing, that is strict token based billing. Okay, right. So the one which we have seen, strict token based. So we have seen the high volume log analysis. Now we'll see the strict token based billing. Some additional example. So here I'm again generating some logs. Okay, so again there are three four services in e-commerce. There is a CRUD call and there is a URL or endpoints are getting logged. Okay. Now before that I will just delete this file. Okay, and I'm doing this Olama way. So specify your Olama cloud and all. That is fine. So first thing is I have to generate the logs. Okay. So what is this strict token based billing? So as I said, if you want to pass on this chunking to some LLM model, okay, so that is why this LLM model I've used. Then this LLM model I have to pass in some chunks, and that chunk will have some limit. Okay, so some fixed number of characters. So that is why this all code. So for now I'm using this model name, which is cloud, which is DeepSeek cloud. And if you see, I'm using this API key, and it is a Olama AI model I'm using, which is this Olama AI model. Okay, right. So there is some standard code, and if you see here, there is a um, data folder where I have to pass on this Olama API key. So this key you will get from the Olama portal. Okay, so there you can give it, take it from there and paste it. Right. Okay. Um, so this is some code for the Olama token passing. So Olama token chunking, it will convert the text to token IDs. Okay, so right, so set your budget safe token limit. So yeah, this is important because I am saying it is a fixed size chunking, and I am saying it is for the billing purpose. I need to set some limit. So in the first example we have set a limit which is 100 character. Here I have set a limit of 40 character, which practically maybe may differ in case to case by case basis, but for now I'm using chunk as 40. Okay, I'm providing the logs, and then I'm getting the tokens and chunks, and then I'm verifying that things are happening as per the requirement or not. Okay. uh, yeah. Again, this is one validation part, which is this validating the chunks. Okay, and this is the auto validation report. This is the main about the automation validation report, where I'm doing the token size compliance, I'm doing the data integrated test, and so on. Okay, so let's run this. Because there is a Olama call is involved, so that is why it will go call the APIs, and that is why it will take a little more time. Okay, for now we can ignore this warnings, because anyway it's a demo. So total token processed are 3690. The budgeted chunks are 91. Okay, so first chunk, second chunk, and so on. I can print the other chunks also. Okay, auto validation report, token size compliance pass, because I'm hard coding it to 40 characters, and data integrity is fail. Okay, which practically may fail, may pass, and we have to look into it. Okay, so data integrity is basically the data integration passed or not, right? So integration passed. Okay, so here integrity check is basically compare original and reconstructed and ignoring the white spaces. Okay, so you have some data that you convert into fixed size chunking and then pass it on to Olama or some AI model, and then you get a response. So that integrity it is checking, and probably it is because of the special characters and all. That is why it is the integrity is not matching, but text wise integrity is matching. Okay, so we have seen that size compliance is matching, data integrity is failing anyway, and sample breakdown. So every token is having 40 characters, and that's why it is passed. Okay, right. So this compliance we can tweak, we can work around, okay, we can have a workaround where it will match the original text and the new text, ignoring the special characters, or whether the as a whole content retrospective it is matching or not. So that thing we can implement. Okay, now next is we have uniform data tables. Okay, so uniform data tables where chunking rows of raw data or CSVs. Okay, right. So here again I have to generate some data. Okay, I am generating some data here. I will not go into detail. There is some data I am generating, and it will be dumped into a CSV file. So let's do one thing. Okay, so there is no data here, right? So sample of CSV raw data, and then I'm doing the chunk size is 10 rows per chunk. Okay, because it's a CSV, so it will not have a huge data. So every 10th line or total 10 lines I can do as a size match, fixed size, which is 10 rows, which will typically match the data limits requirement. So I'm doing a chunking and then visualizing the outcome. Okay, so just I'm printing the total chunks and all, right? And then I'm doing a verification of the actual validation. So being from the automation or the testing side, I need to verify whether the uniform data tables chunking is properly happening or not. So that is why I'm expecting this timestamp service action latency. This is again some hard-coded values, but the header thing we can compare it with the original one where the data is getting generated. And then I have a method which is validating the tabular chunks. Okay, so where I'm doing schema, is there intact or not, headers present in all, row fragmentation is found or not, chunk reports and all. So this we will see in the report. Okay, so we will see the consistency of the header, schema integrity, and number of rows fragments. Okay, so let's run this. Okay, this was quick. Okay, so samples of raw CS data. So again, there are some 4 or 5 samples I've taken, but in practical there will be n number of logs, n number of rows. Okay, right. So then there are 100 rows. I printed only 4 rows. Okay, but we can print all the rows. 10 rows is the chunk size, and total chunks are 10. So there are 100 rows, 10 rows, and 10 chunks. So output, if you see the chunk, so first chunk will have 10 rows. Okay, 1, 2, 11. Okay, so this is the header, and these are the 10 lines. Okay, so that is how it is. 10 rows chunk is getting generated. Okay, so second chunk, and so on. Now tabular chunk validation report. So I'm doing a automated QA validation. That is why it is a tabular chunk validation. So here, if you see, it has passed the header consistency. This is the header, then schema integrity, okay, and number of rows, which is 10 rows. So for chunk 1 to 3, 1 to 5, everything is passed. Okay, right. So we have seen three examples for for the fixed size text chunking. Okay, now demo also we have seen. Now there is a bonus. Okay, so let's see the bonus part. Right. So step 2.4, data chunking techniques. So fixed size chunking for audio processing. So far we have seen it for text processing. Now we will see for audio processing, right? So in the context of audio RAG, fixed size chunking is applied to the transcripts generated by speech to text models like Whisper and so on. Because audio transcripts often lack punctuation or logical paragraph breaks, especially in the spontaneous speech, or there's some podcast going on, there's a live debate going on, live cricket matches going on, so there's a commentary going on. So we need to process that commentary or that live thing, and then give the subtitle or the captions. So there, this fixed size chunking is the most preferred technique to be used. Okay, now what are the other situations where this is must? So where we have low latency live streaming, yes, I have seen, as I said, broadcasting, podcasting, or some live commentary. So that time this is must. budget capped audio summarization. So when you need to summarize 10 hours of audio but only have a limited money API budget, so then you go for this fixed size chunking for audio. uh, you chunk the text into exactly, let's say, 2000 token blocks to calculate the cost before hitting the send button. Right. So again, this is coming from practical experience, practical example, where we can use fixed size chunking. Right. So we'll see a demo. So demo for audio. So as of now, I have converted one audio file into a text file. Okay. So this is one text file. This is a speech to text, and then again I am doing the fixed size chunking and then verifying the chunks info is expected or not. So again, we have the data. Okay, we have the data, and token based fixed size chunker I have done with this method. It will convert it into chunks. Then I will have the audio chunks. Okay, I'll call this method, and then I'm going to verify that these are the. So after conversion, I have this info. Now I have how to verify, because from testing side, from automation side, we need to verify this not manually but automatically. So for that, I have a validate audio chunk and limit I'm passing, and then it will just do the internal check. Okay, so we'll see this, we'll run this. Okay, and let's see the output. Right. So sample, so 59 chunks are created, first chunk, second chunk, third chunk. So we can give the content of the chunk. Again, for the first chunk I am just printing the total 40 or 50 characters, but it can be more number of characters. And the validation part, so user auth spiked at whatever. Okay, this is the validation part. So chunk 1 to chunk 59. Okay, and most of them are using 40 tokens, which is good. Okay, so for some of the other thing, there is a timestamp cut. Okay, all right. So again, this is again, it is a token based, so there should be, so there should be some API limit and there should be some timeout. That is why for some of the tokens there is a timeout limit. Okay, which practically is okay. Okay, because many times we don't have control on what info we are passing to the LLM. So this is, in a way, it is good to reduce our overall cost and save time. Okay, so this is for the audio, and there's one more bonus which is for the image. So okay, so we have seen text, we have seen audio, now we'll see image. Now, this is a bit tricky because it is not straightforward English text or some kind of text. It is basically an image. So fixed size chunking in this context, what is in terms of image, so that is basically in vision rag or vrag. Fixed size chunking involves dividing the image into a uniform grid or patches. Okay, so let's say 16 by 16 pixel or 500 by 500 pixel, whatever, before converting them into visual tokens. Okay, so the term here is visual tokens. Earlier it was text token, now it is a visual token for a transformer based model like VIT. Okay, vision transformer or clip. This might be a bit heavy to understand, but then, as I said, this is bit tricky because it is not a text; it is an image. So we have to divide it into small images or so-called tiles. Okay, so which are the situations where this will be useful? So ideally, if you see any satellite imagery, right, it's a the once a satellite takes one photo, it is a huge resolution. So we cannot process every entire image in one go because there is a resolution constraint. Because if you have more resolution, then the processing power needs to be more, and sometimes it might slow down the system, and of course there is a cost involved. So slicing massive high resolution geographic maps into uniform tiles to detect specific objects like building and shapes and whatever. Okay, so here I have a data where there are some high resolution images. So for example, let's take this one. So by the way, this is basically, if you see, this is basically 127 MB. Okay, so it's just one file which is 127 MB, one photo. right? So 127 MB, 127 MB is the size, just the size, and that too it is just one photo. So imagine if the satellite is taking thousands of photos every day, millions of photos every day, processing 127 MB file in one go is very time consuming, very costly. So, and if you see this image dimensions, 34,500 pixel into 20,100 21,000 pixel, so it's a huge big image. Okay, let's take this one. So the size, file size 12 MB, okay, and the details are, you see 10,000 by 10,000 pixels, so it's a very huge file. Let's take this one. It's a satellite image. So this is 33 MB. Okay, 33 MB is for one image file, which is very huge, and it is again 20,000 pixel by 20,000 pixels. So just for the sake, if you say this image, okay, this is one satellite image. Okay, so let me just zoom on this part. Because it's a satellite image, I can see a lot of things in detail. Of course, not, let's say, up to 100 meters detail, but if you see, I can, able to see the cars and maybe able to see the highway with the cars and so on. Okay, right. So if I want to process this huge high resolution file, then this fixed size chunking is one of the good option. Okay, and let's see one demo. So image, right? Okay, so image. So basically, what is going to happen is this, that uh, this from the developer side, what they will do, they will convert one image into chunks. So chunk here is basically different tiles of resolution, let's say 224 pixel. Okay, this number can change based on the particular requirement, but I'm just choosing 224. And let's just see. So this is for the image 2. So image 2 I have chosen, which is basically 12 MB. Okay, so 12 MB is fine. So there is no tiles folder. If you see, there is no tiles folder here. Let me just run it. So it will open this file, the second file, and convert it into small images or tiles. Okay, so there's a folder called as tiles, and if you see, there are the images which got generated. Okay, let's take this one. So this is the images generated. Okay, the tile is generated. So if you see the properties, right, so 19 KB file, okay, acceptable, and the pixel and the dimension is 224, which is easy to process. Okay, it will not take much of the resources, right? So right, so this is the development part where the image is getting converted into fixed size chunks or tiles. Now let's see um, from the automation verification point of view, because we need to verify this at every time. Okay, so what it is doing, it is validating the image chunk. So basically it will go and open every image in this folder. Okay, every image in this folder, and it will check the size. Okay, it may try to match the tile image. It will, let's say, match this image into the original image, but that will cost a lot of time. So in the interest of time and in the interest of expensive operation, we just verify the dimensions. Okay, right. So let's just run it. So I'll delete this once again. Okay, and it will generate the tiles. Also it will verify. So if you see, it will do a dimensions check, coverage check, pixel integrity, and errors. Okay, so dimensions is passed and full coverage is also passed, right? Okay, so that is for the uh, image part, right? So yeah, that's about it. So we have seen data chunking. We have started with data chunking, this chunking strategies, and we did it for text, we did it for audio, and we also did it for emails. So that's all about this first part in the chunking series. If you like the content, please like, share, and subscribe to my video channel. Thank you.